Okay, let's continue to work on 2.7. In this section, we're going to talk about linear inequalities and the problem solving. We will focus on the first objective. Let's see, the most important part here is you need to learn how to graph your inequalities on a number line. So the first objective is just about graphing it on a number line. So let's check some examples to help you understand how can we graph the inequality. So first, let's say we have this x greater than or equal to -1. So basically we will have a number line 0, -1, -2, -3, and so on 1, 2, 3. So if we want to draw the graph, so first step, we're gonna find what's the value. It's -1, right? So we should locate the value here. It's -1. Second step, we need to determine the direction. So if here is x is greater than or equal to, so we know the direction should be to the right. So we start from the -1 and it goes to right side. I will put an arrow to the right, shows the direction. So the last step, we should work on the single value. So the single value here, -1. Let's check if -1 is a possible value for x. Because here we know the inequality symbol includes the equal sign, which means -1 is possible. So I will choose to put a circle here and make sure this circle is a closed circle. Which means -1 is also included. So this is the first example. We can check another one. This time we have this inequality. It's -1 is greater than x. So I would say for this kind of problem, I will first try to convert this inequality to the equivalent one. Let's say if we say -1 is greater than x. In other words, it's just x is less than -1. So after we switch the inequality to the equivalent one, this one will be much clearer for us to draw the graph, right? We still need to draw the number line and label the number first. So first step, let's check the value, -1. So we need to locate the value. We locate the value first, -1. Right after that, we determine the direction. So here it's less than, which means we should go to the left. So this time I put an arrow to the left to show you the direction. So the last step, we need to work on the single point, single value. Here is -1. And we check this inequality, we realize there is no equal sign included, right? So which means -1 is not the possible value. So I will put a circle, but this time make sure you know this circle is open. It's not closed. It's open circle means -1 is not included. So let's check another one. This time we have an interval. I would say I have two values because we have two values. So first, we should locate these two values. So first is -4, right? Another one is 2. So which means we should draw a line from -2. So this time it's not an arrow, it's just a line segment, right? It's from -4 to 2. Then the last step, we need to figure out the single point. The single point for -4. Is that possible to be exactly -4? When we check the inequality, we realize for this -4 side, there's no equal sign, which means we should put a open circle for -4, which means -4 is not included. But let's check the 2. The single value 2, is that a possible value for x? Because we realize here it also has the equal sign, which means 2 is possible for x. So for the 2, we need to put a closed circle, which means 2 is included. So that's for the first topic. And I will say in your chapter test, you will have this kind of questions. You need to know how to graph, or which graph is correct for the inequalities. So let's check objective B. We should use the addition property to solve the inequality. Okay, to solve the inequality, addition property. So what is the addition property? Basically, we have this rule. If A is less than B, then A plus C is less than B plus C. So it's just the same. If A is greater than B, we have the same rule. For the addition rule, no matter C is positive or negative, the rule is always the same. It's always the same. Both sides plus or minus a number. Okay? The direction of inequality will not change. Will not change. So let's check some examples. If we have this inequality, we want to solve this inequality, we still need to isolate the x. How can we do it? We should set x on one side, and for this part, we should -4 for both sides, right? So -4, we can treat it like plus the -4. So it's just the same. So the addition rule is also valid for the subtraction. So here we will get x is less than or equal to -10. Because both sides we plus a same number or minus the same number. They always remain the same inequality symbol. Okay, after that, we can use the number line to represent your So for this question, we locate what is the value first. It is the -10. And after that, we check the direction. We know it should be to the left. The last one is we need to check the single value, -10. So at that point, is that possible to be exactly negative 10? Because here we have the equal sign, so it's possible. We put a closed circle here. All right, this is how we using the addition rule. Again, addition rule, you can treat just the same thing as the subtraction rule. Because if you treat minus a number, you can treat it like plus a positive number. So next objective is the multiplication rule property. Multiplication. 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 Okay. So basically we have this rule. Not just the same as the addition rule. Multiplication rule is different. Here, if A is less than B, if C is positive, then we can say AC is less than BC. So which means we can multiply by a positive number to each side of the inequality, and the symbol will not change the direction. So only if C is a positive number, then the inequality will not change the direction. But if we want to multiply a negative number for both sides, so this time C is a negative number. A times C, B times C another side. Make sure you know there's a big difference. So we will say the inequality sign change the direction. So reversed. Okay? A less than B. If C is negative, then AC is greater than BC. Make sure you memorize. It's not like the addition rule. For addition rule, no matter the positive, C is positive or negative, always true, always not change the direction of the inequality symbol. But for the multiplication rule, you should very careful about the inequality symbol. The direction will change sometimes. Let's see the example. So we have this. Negative 2x minus negative, not minus, less than or equal to negative 4. So we can think each side we divided by negative 2 for each side. So cos divided negative 2, just like C is a negative number, right? Negative divided by negative 2, which means times negative 1/2. So it's the C here is negative, so we should be very careful about the sign. You can write the terms on both sides first. Then make sure you know this time the direction reversed. So this time we have this. After that, we only need to do the remaining part. So the most important part is here, the direction has been changed because we multiply or divided by a negative number. So of course, if you want to, you can try to use the number line to express your answer. Let's check another example. So if we want to solve this inequality, we still need to divide it by the coefficient of x. So both sides we will divide it by 2. So this time, 2 is a positive number. So we know the symbol will not change the direction. So remain the less than sign. So next, we only need to do the remaining part. Okay, if you want, you also could use the number line to show your answer. So that's objective C. So next one, we will talk about to use both addition and multiplication property to solve the inequality. Okay, let's just check the example. So it's very similar as the problem solving of equation, but the only difference is when we try to divide or multiply by a negative number, the direction of the inequality symbol should change. So the remaining part is just the same. So let's go to check this question. So first of all, we should isolate the x term. So we use the addition rule. Both sides we minus 7. So for the addition rule, we'll never change the direction, right? So we will have negative 4x greater than. But next step, we're gonna divide it by the coefficient of x, so which is the negative 4. Right? It's negative 4. So both sides divided by the negative 4. We should be very careful because negative 4 is a negative number and we're gonna divide it by it. So it's the multiplication rule. It's the multiplication rule. So we should be very careful about the inequality sign. We know this time we're gonna change the direction of it from greater than or equal to the less than or equal to sign. So after that, the remaining part is not hard. X is less than or equal to 4. Okay, so if you want, you can also change also use the number line to express your answer. Okay, so let me show you another example. So this time, so in this inequality, we know first we should use the distributive rule. So we also need to use the distributive rule on the right side, right? But make sure you do it carefully. After that, we can combine the like term. After that, we need to put x terms on the side, one side, and number on the other side. So minus 2x we doing that, we realize then we plus 12 for both sides. We will get 1 is less than or equal to x. Of course, we prefer to put x on the left side, so we will switch this one into x is greater than or equal to 1. Alright, so last objective is to solve problems modeled by inequality. So we have some at least, at most, to make sure you know at least means no less than, at most means no more than. So for these two kind of things, we also included the equal sign. So let's try to check. So I think maybe we do not have this kind of questions in your quiz or in your text, but we just learn how to do it if sometimes you have the opportunity to see this kind of questions. But I think it will not be in your quiz. So let's just see an example. This time we have 12 subtracted from 3 times a number is less than 21. We want to find all numbers that make the statement true. The statement true. Okay, so here, after we read this one, we realized we should find a number, right? We should find all the numbers are qualified. So here, a number is our x. Because a number is unknown here, we just translate number 2 in x. So after that, we try to translate the words into the inequality. 12. We just put 12 here. Subtract from, so which means we should minus 12. From what? 3 times a number. 3 times a number, because number is x. 3 times a number, we will use 3x. Right? After that, we know it's less than. So we say less than. It's just less than 21. So after that, we finish to list our inequality. Next step, we should use both the multiplication and the addition rule to solve this inequality. So first step, we should add 12 to both sides. Again, when you add some number or minus some number to both sides, the direction of your inequality symbol will not change. Right? So next step, we will have this. So this time we should divide by 3 because 3 is the coefficient of x. So we divide it by 3. 3 is a positive number, so we don't need to worry about this the inequality sign because the direction will not change. So the remaining part is just like this. So for the inequality or the equation, we need to read the question carefully, maybe multiple times. Then set the unknown to be our variable. Then try to translate the sentence into the expression, to be the equation or the inequality. After that, we only need to solve our inequality or equation. So the basic rule for solving the inequality and the equations are very, very similar. The only difference is the multiplication rule for inequalities. Remember, just watch the sign. Sometimes, if you need to multiply by a negative number or divided by a negative number, the direction of your inequality symbol will change. Okay, that's the most important part for inequalities. So that's all for the chapter 2, I think.